All right, so the appropriate quantity for liquefied natural gas, LNG, in tons produced by an energy company increases by 1.7% each month as shown in the table. So to go from January to February, there's a 1.7 increase. And to go from February to March, there's a 1.7% increase. So now remember that when we talk about growth, one way to define growth, especially if it's a percentage, is the previous amount or whatever amount you're starting with, and then you're including that amount, and then you're adding the point. You got to write the 1.7% as a decimal, and so that you just move the decimal 2 spaces to the left. So you're adding 0.017. And then this represents the number of times, like how many months you're going to work on that or whatever, or how many, because the growth is the same every month. So this would be some variable, right? It could be t, it could be n times t, but this is tracking the time. You're going to raise it to that power. And so these are what we call common ratio problems, right? Sort of, because I'm really just multiplying by the 1.7. In fact, if I was staying true to this geometric sequence, I would just multiply by the common ratio. But one of the things that we have to do is we have to write the explicit. So this is what we would call the explicit equation, right? It's a fancy version of it, but this is the explicit equation. So I'm going to start with this initial amount, and then I'm going to multiply that by this. But then remember that the explicit amount usually starts out as n minus 1, because when if January represents 1, when I plug the 1 in here, this whole term here is raised to the 0, which is just going to be 1. And then 1 times this is this. So that's why we have the n minus 1. So now they want to know approximately how many tons will be produced in May, and approximately when will this amount be done. So this is the beauty of taking a geometric sequence with a common ratio. In other words, we're multiplying by we're multiplying each term by 1.017. So to get from this to this, and to get from this to this, we're multiplying by this common ratio of 1.017. So because I've written this in explicit form, which is an actual equation, I can do some things. So I'm going to let January be the first month, February be the second month, and so on and so forth. So May is the 5th month, right? Because April's the 4th month. So what I'm going to do is I'm going to plug this in my handy dandy calculator as a graph. And I'm going to say 88,280 times, and then in parentheses, I'm going to put 1.017, close my parentheses, and raise that. Now here I got to put x minus 1 because I don't have n, right? Now I'm just going to jump right here to the table, so I'm going to hit second table. And let me zoom in on that so we can see the values of this. Actually, you know what? I got a better idea. Let me show the screen of this. So what I'm looking for on the first month, which is January, it's 88,000, right? It's the 88,280. And then if you look on the second month, which is February, I've got this 89,781. So that's important to check that. And then on the third month, again, I have the 91,307. So my formula works for the first three. So then in April, I have 92,85. And then in May, I have 94,438. So let's jot that down real quick. So in here, I have 94, 438. 38. I don't like that 1, 4. You can't really make out that that's a 4. So in fact, I'm just going to do it like this because I'll get a bunch of emails. What is that number? So right here, it's going to be 94, 438. And then it wants to know, the next question is when or what month will be at 104, 489. So 104,489. So let's look at that and see. So I'm just going to scroll down until I get to that number. Okay, there it is right there. That's the 11th month, which is November. So in here, I'm just going to say November. And that's basically it. That's basically it.